Let's talk components of a transformer. So on the surface, transformers are pretty simple devices. It's just two coils of wire that are near each other, and you run AC through it, and you can transform, right? Now, when you're designing a transformer, though, you have to consider different things. You have to consider the amount of current that you're going to be pushing through it. You're going to have to consider the voltages, right? You're going to have to consider the application and where they're going to be placed, and security of the device. Make sure people are safe that are going to be working around and near it. Weather is going to be a factor. So there's a lot of things that are going into designing transformers. So when we're talking larger transformers, such as distribution transformers, power transformers, all right, there's some typical components that come with the transformer. So the first, we have the core of the transformer. So the core is the iron core that the windings are wrapped around. And what that core does is it creates structure for the windings to hold them up. It also concentrates the magnetic field, so it makes it a little bit more efficient. They're usually laminated in laminated sheets, and we'll talk more about what those do, but those are to prevent and reduce the effects of eddy currents and hysteresis. And then there's also the magnetic path that it creates. Like we said, it increases the magnetic path, makes it more efficient. It concentrates it so that way you can have a better electromagnet, essentially, with less material. So that's the core. And then the next one is the windings. So the windings obviously are such a part of a transformer. They are the wire that is wound around the core. There's usually a primary winding and a secondary winding. Typically, the primary winding is the higher voltage. Secondary winding is typically the lower voltage. That's not always the case. It could be the opposite. But you could always guarantee that the primary winding is the winding connected to the source, the power generation side. And the secondary winding is the winding connected to the load or the customer. So that's what determines the primary and secondary winding. Next, you have the insulation oil. So some transformers are dry type and there's no oil inside of them, but some are liquid type. Majority of distribution transformers and power transformers are oil type because they are so large and you're pushing through so much current and energy that they need a little bit more effort to help cool down the transformer and protect the transformer. So the insulation oil provides electrical insulation between all the different parts inside there. It also provides an opportunity to cool the transformer. So it absorbs some of that heat, and then you can cool the transformer using the insulation oil. There's also oftentimes a tap changer built into the distribution power transformers. So a tap changer adjusts the winding ratio to account for voltage losses in the line. Typically, distribution transformers, you adjust that when you install. You have to do it when it's de-energized. You adjust the tap changer, you set it, and you move on. You're not constantly going out there and changing and adjusting the tap changer multiple times. Power transformers that step up the voltage just outside the power plant generation facility, those can auto tap change, right? They have an auto changer that can do it under load automatically. And the reason behind that is because to de-energize such a key transformer right after the power generation, you would have to shut down a very large portion of the grid to make adjustments. All right. And as the grid changes, more load is brought on, the voltage can drop. So to make those adjustments on the spot without de-energizing and shutting off a big portion of the grid, those ones are designed to change under load, but those are very rare. Next, we have the bushings, right? So to account for the high voltages, the bushings are where you make the electrical connections to the transformer. So it is the exposed electrical part that comes out of the casing of the transformer. That's where you connect your cables. Sometimes these can be high voltage, so you have to have bushings to kind of protect that exposed without it arcing across. So it needs to be a large insulation portion, and needs to have mechanical support for those conductors. And those are the bushings. You'll have the ones on the primary side, you'll have some on the secondary side. They may be different sizes depending on the different voltages from high to low or from low to high. And then next you have the tank, right? So the tank is the tank that the transformer is all enclosed in, the enclosure, the tank. It protects the transformer windings, it protects the structure, and it usually has some sort of locking mechanism so that way not anybody can walk up and open it. It contains the oil. It usually has oil valves where you can take oil samples from. You can open it up. You can do your testing and inspection. That's your tank. Next, you have a cooling system. So larger transformers will have some sort of external cooling system. They may have fans and pumps. They may be pumping water through the transformer. They may be pumping the oil through. They'll have radiators built onto the side. So as that oil heats up, it goes into the radiator. It rises up through the radiator with air flowing through the radiator blades, cools it, goes back into the transformer, absorbs the heat, and continues the cycle. If that's not enough, then you could add fans to help cool that radiator as well. So you have powered fans to blow more air through them. And then you also might have cooling water that's run through the transformer through separate tubes that are separated from the oil itself. They're not just filling it with water, but they have water tubes running around the core of the transformer internally that are highly cooled water, absorbs the heat, goes back out, gets cooled down again, and pumped back through. There's a couple more components. There's the Buchholz relay. So this relay serves as a protective device that detects the presence of gas in the oil, which can be very dangerous. So if it detects that, then there's some sort of issue with some sort of breaking down or arcing inside the insulation. So this will kind of shut the transformer off, de-energize it, so that way technicians can come and inspect it. There's also, you might also have a conservator tank. So the conservator tank is an external tank that allows for the expansion of the oil. It's got a diaphragm, a bladder, and might have a breather. So as that oil is heated up, pressure might increase, might expand. So it needs someplace for all that to go. So that's a conservator tank. Other than that, those are your basic components of transformers. The main parts that you will find in all transformers are the winding, the core, and the enclosure. But for larger transformers, you'll have additional components that we just discussed.